Today I would like to discuss about single fiber single wavelength SFP transceiver made by OE Solutions. This is an advanced version of single fiber bidirectional solution that are available in the market. Traditional single fiber bidirectional transceiver uses two different wavelengths, meaning that you have a filter inside the transceiver, and transmitter wavelength uses one wavelength, and the receiver side uses another wavelength. There is an advantage of having a single fiber bidirectional transceiver, but by using single wavelength on top of single fiber, you basically add a few more advantages in the system. In this slide, I'm showing here advantages of using single fiber, single wavelength transceiver. First of all, the advantage of a single fiber traditional bidirectional solution is basically it saves the fiber lease cost, and it simplifies the fiber management, and CWDM solution can also enable more flexible and future-proof system. On top of this technology, where it uses the two different wavelengths, you are basically using, even though you are using one fiber, you are using two different wavelengths. So number of ports can be limited. In our single fiber, single wavelength solutions, basically you do not use two wavelengths for one link, so that you can actually increased number of wavelength usage. In this diagram, I'm showing here just an example of a wireless backhaul system where it utilizes the CWDM wavelength. Here you have a 2G service, you're using 1310 and 1550 wavelength. For 3G, you're using 1510 and 1570. Again, for each link, it uses two different wavelengths. But for WiMAX case at the bottom, you do see here 1450, 1470, and 1490, and then you can basically have three different links with the three different wavelengths. Another advantage of using single wavelength solution is you can reduce the number of MUX and DMUX. I will show in the later slide how this can be done compared to traditional design, but that's another advantage. And one additional advantage would be operators can basically use same wavelength parts for each link, so that there is no need for having two different parts for one link. This can cut down significantly for inventory situation. Also, technician doesn't have any chance of making a mistake on inserting wrong transceiver in the port. So how does single fiber, single wavelength SFP transceiver work? Basically, we do have both shown here. Instead of using thin film filter, we are using beam splitter that splits the beam into half. So you see here, going out of the laser, you do have a lambda 1 going out, and then hit the prism, and then half of the light goes into the light absorber, and the half of the light goes out. And then for incoming light, you do have light lambda 1 prime coming in, and then half of the light goes into the photodiode, and then another half goes into the isolator. So because of this design disadvantage of having this is adding an additional 3 dB loss. So for each end you introduce 3 dB, so in total it adds 6 dB in total. So that would be a main downfall of using this technology, but other than that, when I can list out all the advantages. So here in this slide, I'm showing mux and demux that actually connects lambda 1 through lambda n. So by using this single wavelength solution, you can utilize all n number of wavelengths instead of n divided by 2. And for, as you can see in link calculation, it can have as much as a link budget of 15 dB, which can be enough to have a transmission distance of 20 kilometer. So because only one fiber and one wavelength is used for each link, there are many advantages. So first one would be, as I mentioned before, inventory control. It is easy, and also since the same part is used for both ends, you can cut down the number of parts that service provider has to keep in their stock. And as I had explained before, only one fiber and two optical mux-demux is used for the system. If you do use conventional duplex type CWDM SFP, you would have to use 4 different mux and demux for the same type of a link. So that would be actually a huge advantage of using single fiber, single wavelength SPD solutions. Downfall again is a 3 dB loss at each end, so it is not really geared toward for longer distance application. And to be on a safe side, we do recommend APC type patch cord instead of a UPC. This is to reduce the reflection going into the laser.